For the area that I have here, I want to find the location of the centroid. So I need x and y coordinates. So we'll start with the x coordinates, and the equation that we're going to use to find the x location of the centroid is the integral of x tilde times dA all over the integral of dA. So we've got to kind of define what dA is. And the way that we're going to do that is by drawing a thin rectangle at some arbitrary location. So I'll draw that thin rectangle right here. Okay, and so that thin rectangle has a thickness of dy, right? And a width of, let me see here, that is a width of x. Okay, so the area of that rectangle, okay, which is going to be dA, the infinitesimal area of that is going to be that x times the dy, basically the length times width. Okay, now the other thing I've got is that x tilde, which is essentially the centroid of this area, which will be right in the center of that rectangle. That's going to be located at distance y, okay, which we won't use here, but we'll use in the y equation, and then a location of x over 2. So that's the location of the centroid of that dA. So we draw the thin rectangle dA. Okay, now we apply it to this equation here, where I'm going to take my integral, okay, of x tilde, which for us is going to be x over 2, times dA, which is going to be x times dy. Okay, and my limits of integration here, I'm integrating with respect to dy. Therefore, I go in the y direction from 0 all the way up to 9. Okay, the denominator will look the same. It will just not have the x over 2 in front of it. Okay, but now here's the thing. I have x's and y's. I need to get everything in terms of y so that I can integrate it. Okay, and I have an equation for the line there, okay, which I can reorient, basically say, okay, well, x squared equals 9 minus y, and then x equals the square root, which I'll write as 9 minus y to the 1/2, like so. Okay, so now I know what x is. Okay, I'm sorry, yeah, I have x in terms of y, so now I can get everything in terms of y here, which is what I'll do here. So again, I'm going to integrate from 0 to 9, okay, and I'm going to have 1/2 x squared, right? But now I know that x squared is 9 minus y, okay, which I take times dy. Now I have an equation that only has y in it that I'll be able to integrate. Okay. Similarly, on the denominator, I go from 0 to 9, and now x we know to be 9 minus y to the 1/2, or the square root of 9 minus y dy. So again, now I've got equations that I'm going to integrate with respect to y in terms of y. Okay. Now, I'll assume you know how to do integrations of an equation like this. You can always use a calculator if you don't want to do it by hand. And the numerator, I get 20.25, and the denominator, which is the area, I get to be 18. Therefore, this becomes 1.125 feet. Okay, so that is the x location of the centroid. Okay, for the y location of the centroid, I get a very similar equation, delta y all over the denominator dA. Now notice the denominator is exactly the same. If I integrate dA, okay, then that's just going to be a, which we found to be 18, and that's going to be square feet on that. Okay, so difference this time is now instead of x tilde, I'm going to use y tilde. Y tilde again is some arbitrary location y. Okay, and dA again is x times dy. I am still integrating with respect to y here, so my limits will be 0 to 9. However, the denominator I've already solved. I'm not going to bother solving it again. I get to be 18. Okay, so now the same idea here. I need to get everything in terms of y. So I'm going to go 0 to 9, and instead of y times x, I'm going to go y times 1 minus y to the 1/2 dy. Again, the denominator is still 18. Not going to resolve that, but I get that right there. Now, integral may be a little bit more challenging. Okay, however you want to do it, by hand or on a calculator. I get 64.8 for the numerator, and the denominator gets to be 18, which gives me 3.6 feet. Okay, so again, what that's telling me is the location of the centroid, which gets a little messy in here, right? But if you go in the x direction, 3.6, and then up here, I don't know, maybe up to here, we'll call that y tilde, right? And, x tilde is going to be somewhere right around there. Okay, so again, I getting a little messy here, but this is essentially your centroid. Okay, that we're trying to find. Okay, and again, you do that using those equations, using a thin rectangle, writing that in terms of my x and y, and integrating that equation and solving appropriately.